Alright, this is the PhysioX lab for digestive physiology for Daytona State College. What we're going to do is use 7 test tubes and put different enzymes, different substrates, and test for different products. The first test tube we're going to do is going to be amylase and the substrate starch, and we're going to use a pH buffer of 7. And for this test tube, what we're actually going to do is we're going to drop it down and we're going to boil it. So we're going to see if boiling has an effect on the proteins that make up the enzyme amylase. So we're going to do test tube number 2, the same as test tube number 1, except for this test tube number 2, we are not going to boil. Beautiful. Test tube number 3 is going to be amylase, which is our enzyme that dissects starch into simple sugars. We're going to have deionized water, and we're going to have a pH of 7. Notice in this one we're missing the substrate. For the next one, we're going to have deionized water, we're going to have starch, and we're going to have a pH buffer of 7. On this one, test tube number 4, we are missing the enzyme. For test tube number 5, we're going to have deionized water, we're going to have maltose, which is sugar, and then we're going to have a pH buffer of 7. And then for the next two, what we're going to do is we're going to alter the pH. We're going to add amylase, the enzyme, the substrate starch that amylase works on, and the first one's going to be a pH of 2, and then the next one we're going to do is going to be a pH of 9. So substrate, amylase, the enzymes, and pH buffer of 9. For this next one, we're just push the incubation button, and it's going to incubate it for what would be 60 minutes, but it's only going to take about a minute to elapse. When we test for sugar, the test for sugar is called Benedict's test, and Benedict's reagent turns orange once you heat up Benedict's reagent, and the test for starch is called iodine, or IKI. So we can use iodine, and iodine in the presence of starch turns black. So the idea is, if amylase breaks down starch 100%, we should not see any positive starch test, but we should see a positive sugar test. The next experiment is very similar, but what we're going to be doing is we're going to be testing freezing of the enzyme versus heating. The goal is to determine, does heating and freezing have the same effect? When we heat a protein up or an enzyme up, we're going to physically change its characteristic by changing its physical shape. And in doing so, we should make that enzyme inert. And when an enzyme that has been changed and isn't able to function, we call that it's been denatured. So we're going to divide this into 2 groups. We're going to have starch on the top, and we're going to have sugars on the bottom. Looks like test tube 2 didn't take. Test tube 2 again. We're going to do test tube 3. Number 4. And even though this is a computer simulation, we can do the same exact experiment with real test tubes, with real starch, with real sugar, with real Benedict's reagent, and with real iodine. Okay? So for the top, what we're going to do is we're going to add iodine to each of them, and again, iodine in the presence of starch should turn black. Once this completes, we're then going to add Benedict's reagent to the bottom one and test for sugar. And like I said earlier, we must heat up Benedict's reagent. We're not going to boil it, but we're just going to warm it up. And Benedict's reagent in the presence of sugar should turn a nice orange hue. If you're doing this as a wet lab, it actually will turn, for example, Sprite, which is clear. When we put Benedict's reagent, which is blue, inside it and heat it up, it's going to turn bright orange like you had a test tube full of Tang. Alright, so now that we have this right here, let's go ahead and push the boil button, which is just going to warm it up a moment, and there it is. Beautiful. So test tube number 1, we have a positive starch and a negative sugar. We have a negative sugar because the amylase was not able to break down starch into sugar because we boiled it first. In test tube number 2, we have a negative starch test, positive sugar test. It's positive because amylase was given the right pH and the right substrate and was able to break it down during a 60-minute time, all of the starch into sugar. Test tube number 3 was negative for both because we only had enzyme, water, and pH of 7. We lacked the substrate and we lacked the enzyme, so both tests were negative. Test tube number 4 had no enzyme, so starch remained starch, so it was a positive starch test and a negative sugar test. In test tube number 5, we had maltose, which is not a starch, so therefore it has to be a negative starch, but maltose is a sugar, so we're going to have a positive sugar test. Now look at test tube number 6 and 7. Test tube 6 and 7 were positive for starch and slightly positive for sugar, meaning that pH of 2 and pH of 9 were not the optimal pH for amylase to work in, and it was not able to convert all the starch into sugar. So we have both a positive starch and a positive sugar test for pH of 2 and pH of 9 when testing amylase with the substrate starch. All right? And that's all for this experiment.